So our first question is verify Cayley Hamilton theorem. So we know it's stochastic equation, right? So by first of all, we have to verify the Cayley Hamilton theorem. So that means, so what is the characteristic equation here? Here we have to find a characteristic equation by using delta of A minus lambda I equal to 0. So what is the characteristic equation, Amma, here? Have you done this problem, guys?
Yes, ma'am.
Then tell me. So this is 1 plus 3. So lambda square, because this is a 2 by 2 matrix, no? So that's why this will be lambda square minus 2 plus 1, 3 lambda minus minus 2 equal to 0. So this is our characteristic equation, right? Isn't it? So then we need to find our first we have to verify this one. So by Cayley Hamilton theorem, every square matrix satisfies its own characteristic equation. So that's why we have to prove that this will be, instead of lambda, you need to put a and 3a minus 2 into I is equal to, you have to prove that that will be 0. Okay, so that is nothing but 0, isn't it? So after that, so this is verification. Okay, so after that we need to find a power 4. Okay, so here we have otherwise you can simplify by using the polynomial method. Okay, so otherwise you can use a power 4 value. You can find a power 4 value, a cube value, a value, and I value. You have to substitute here, then you will get the matrix. Otherwise you can use a polynomial method formula. So that means a square equal to 3a plus 2i and a cube equal to 3a square plus 2a, a power 4 equal to 3a cube plus this is 2a square. Okay, so now substitute highest power is a power 4, so that's why substitute this value first, then simplify. After that you have to write remaining polynomial as it is, and then next highest power is a cube, then substitute a cube value there, and after that you have to substitute a square value over here and simplify this one. So after simplification, what you will get here? What is your final answer or final polynomial for this question? Have you done this problem or not?
16a plus 8i.
16a plus
8i.
8i. Okay, so actually this is the solution, but if you want to, if you want in matrix form, no, you have to substitute a here. So what is a? A is 1 2 2 2 plus 8 into identity matrix of order 2, that is 1 0 0 1. After simplification you will get the matrix also. Okay, you will get the matrix also. So like that you can find. And coming to the next question. Sorry. So now coming to the next question. What is our next question? Sorry. Second question. So our second question is here. Use Cayley Hamilton theorem. So no need to verify Cayley Hamilton theorem. So directly you can find by using Cayley Hamilton theorem, you can find powers, positive powers and negative powers also. Okay. So here, how to find a cube? So what is the characteristic equation here? The characteristic equation is lambda square minus 3 lambda. Yes, tell me.
Minus 2.
Minus 2. Minus 2 equal to 0. So by Cayley Hamilton theorem, So instead of lambda, you have to put a. So that's why this is a square minus 3a minus 2 into I equal to 0. Okay, so no need to verify the Cayley Hamilton theorem. Directly you can find a cube. So how to find a cube? Multiply with a on both sides, isn't it? So that's why you will get a cube. So a means multiply with a means that is a square minus 3a minus 2i is equal to 0. Okay, so a into a square is a cube minus 3 into a into a is a square plus minus 2 into I into a is a equal to 0. So a cube equal to 3a square plus 2a. Okay, so you have to find a square by using calculator, and you will get this a cube value. Okay, so how to find a cube value? A power minus 3. Yes, what happened? Tell me. How you can find?
Multiplying with a power minus 3.
Roll number 4. So for this equation, we have a power minus 1 on both sides. Then you will get that is a power minus 1, that is a square minus 3a minus 2i equal to 0. So from that, a into a square is a minus 3 into a into a square, a inverse is I minus 2 into a inverse equal to 0. So minus 2a inverse equal to, this will be minus a plus 3i. Okay, so a inverse equal to 1 by 2 into a inverse on both sides. Okay, so from that you will get a into a inverse is I minus 3 into this will be a inverse. Okay, so next from that you will get a power minus 2 also. So then again multiply with a power minus 1 on both sides. Okay, so from that both sides, so from that you will get a power minus 3 equal to 1 by 2 into, so this is a inverse minus 3 into a power minus 2. So already you know a power minus 2 value, right? And a inverse value also. Okay, if you substitute here, no, you will get a power minus 3. So like that also you can find. So otherwise directly you can multiply with a power minus 3 on both sides, then you can find a inverse and a power minus 2 value also. Okay, is it clear, all of you?
Yes, ma'am.
Now coming to the third question, state the Cayley Hamilton theorem. Here you need to write this so find So sorry for the inconvenience. Some network issues there here. Okay, is my voice audible now?
Yes, ma'am.
So now tell me, here we need to calculate a square and a power a inverse, right? So before that, tell me what are the eigenvalues of this particular matrix? Without doing characteristic equation and without finding the roots of the characteristic equation, you can tell. Because this is upper triangular matrix, right? Isn't it?
Diagonal elements are
Yes, if it is upper triangular matrix or lower triangular matrix or diagonal matrix, the diagonal elements are the eigenvalues, isn't it? But you have to do in the exam. So you have to write the characteristic equation, and after that you need to find eigenvalues. You have to follow that procedure, but after seeing the question only you can say, so what are the eigenvalues for this particular matrix? Okay, so here the eigenvalues of this particular matrix is the diagonal elements. So what are the diagonal elements here? 3, 2, 5. So these are the eigenvalues for this particular matrix. Now tell me, so what are the eigenvalues? So this is eigenvalues of A. Eigenvalues of A are lambda equal to 2, 3, 5. Our eigenvalues of A are 2, 3 to 5. And eigenvalues of A inverse are A square. First we need to calculate A square, no? So what are the eigenvalues of A square? What are the eigenvalues of A square?
4, 9, 25.
Yes, eigenvalues of A means that is lambda. Eigenvalues of A square means lambda square. So what are the eigenvalues for A inverse? That is lambda inverse, that is nothing but 1 by lambda, isn't it? So we have a theorem statements or properties of eigenvalue, properties of eigenvalues and eigenvectors. We have discussed about this. Okay, so eigenvalues of A is lambda, no? In that case, lambda, eigenvalues of A square is lambda square, and eigenvalues of A inverse is lambda inverse, isn't it? So that is nothing but 1 by lambda. So eigenvalues of A square means that is 3 square, 2 square, 5 square, isn't it? Eigenvalues of A square is 3 square, 2 square, 5 square. So that means 9, 4, 25. So what about eigenvalues of A inverse? Eigenvalues of A inverse are 1 by 3, 1 by 2, 1 by 5. Isn't it? Is it clear, all of you? Antena?
Yes, ma'am.
Yes. Kindly respond, Amma. So now coming to the next question, if A equal to 1, 2, minus 3, 0, 3, 2, 0, 0, 2, then find the eigenvalues of this one. Okay. So now tell me what are the eigenvalues of this particular matrix? This is also upper triangular,
1, 3, 2.
right? Yes. So if it is upper triangular matrix or lower triangular matrix or triangular matrix or diagonal matrix, the diagonal elements are the eigenvalues. Okay, so here the diagonal elements are 1 comma 3 comma 5. Okay, so eigenvalues of A are 1 comma 3 comma 2. Okay, so but we need eigenvalues of A cube, right? So eigenvalues of A cube is, yes, tell me what happened, guys.
194.
Yes. So eigenvalues of A cube
127
are 1 cube, 3 cube, 2 cube. Okay. So next eigenvalue, we need eigenvalues of A square. So eigenvalues of A square are 1 square, 3 square, 2 square, isn't it? Okay. So now what about eigenvalues of I? 1, 0, 0, 0, 1, 0. This is 0, 0, 1. So this is identity
1,
matrix
1, 1.
because the given matrix will be in the form of order 3. So that's why we have to take the identity matrix of order 3, right? So identity matrix of order 3 means 1, 0, 0, 0, 1, 0, 0, 0, 1. So we have one statement is there, or one property is there for this. So the diagonal matrix eigenvalues are the diagonal elements, right? So that's why eigenvalues for A are 1, 1. The diagonal elements are the eigenvalues. Now you have to substitute all these values here. So in the equation or in the polynomial, you have to substitute. So what is the polynomial here? So this is 5a square minus 6a plus 2i. Okay, so 3 into, so a cube eigenvalues are 1 cube 1 and 3 cube. 3 cube is 27. 2 cube 8 plus 5 into a square eigenvalues 1
1,
9
9, 4.
4 minus eigenvalues of a are 1 3 2 plus 2 into eigenvalues of I is 1 1 1. So if you simplify this one, no, you will get, first simplify that one and tell me what is the answer. So this is 3 into 1, 3 into 27, 3 into 8, 5 into 1, 5 into 9, 5 into 4, minus 6 into 1, 6 into 4, 6 into 2, 2 into 1, 2 into 2, 2 into 3, 2 into 1, 2 into 1, 2 into 1, 2 into 1. Okay.
Ma'am, question number 4 లో Hamilton theorem ఎక్కడ యూజ్ అయింది అన్నారు?
No need to ఇక్కడ మెన్షన్ కూడా ఏం చేయలేదు కదరా. జస్ట్
Ma'am,
ఫైండ్
పక్కన
ది
అక్కడ
ఐగెన్వాల్యూ.
కాన్సెప్ట్ ఆఫ్ Cayley Hamilton theorem అని ఇచ్చినారు.
ఫోర్త్ వన్.
Ma'am, fourth one లో ma'am. Learner to recall the concept.
ఎవరు రాశారా ఇది? సబ్జ్యూమ్ లో అలా రాంగ్ ఉంది. No need to use Cayley Hamilton theorem. Okay, directly you can do. Okay, without using Cayley Hamilton theorem also you can find. So otherwise you need to, ఒకవేళ Cayley Hamilton theorem యూజ్ చేయాలనుకోండి, నేను ఇందాక చెప్పాను కదా. So first you need to substitute all these values and you can find the polynomial in terms of a, then that will be in terms of a and I. You have to substitute all these values here, you will get one matrix. So for that matrix you need to find the you need to find the eigenvalues. So for this particular matrix you will get one matrix, right? So after simplification, if you want to use Cayley Hamilton theorem, no, in that case you have to simplify this one and find the matrix of the resulting matrix. Find the resulting matrix. After that find the eigenvalues for resulting matrix. Okay, ఇలా చేసినా సరిపోతుంది. బట్ ఇదైతే లెందీ అవుతుంది కదా. ఏది ఈజీగా ఉంటుంది చెప్పండి?
నార్మల్ మెథడ్.
దిస్ ఈజ్ ఈజీ, రైట్? సో నువ్వు ఇలా అయినా ఫైండ్ అవుట్ చేయొచ్చు. మనం ఒక ప్రాబ్లం ఫైండ్ అవుట్ చేయాలి అంటే ఒకటే సొల్యూషన్ ఉండదు కదా. నేను ఆల్రెడీ చాలా సార్లు చెప్పాను, ఏ ప్రాబ్లం కైనా ఎన్ని వేస్ లో అయినా చేయొచ్చు. లేదు అంటే నువ్వు డైరెక్ట్ ఇక్కడ సబ్స్టిట్యూట్ వితౌట్ యూజింగ్ Cayley Hamilton theorem ఆల్సో యూ కెన్ ఫైండ్, రైట్? సో నువ్వు క్యాలిక్యులేటర్ లో యూ కెన్ ఫైండ్ a cube and a square value. Already you know that a and I means here this is 3/3 matrix. Now you have to take identity matrix of order 3, then substitute all these values here, then simplify the matrix. So you will get one particular matrix, that is our resulting matrix. After coming the resulting matrix, after getting the resulting matrix, you can find the eigenvalues. Otherwise you can that method also, that is third method. This is a Cayley Hamilton method is second method and this is a first method. So which one is the easy method? No, you can follow that method. Okay, మన కాన్సెప్ట్ ఏంటి, దీనికి ఐగన్ వాల్యూస్ ఫైండ్ అవుట్ చేయడం. నీకు ఏది ఈజీగా ఉంటే ఆ మెథడ్ లో చేసేయచ్చు, నో ప్రాబ్లం. ఓకే, అర్థమైంది కదా? డైరెక్ట్ చేసేయచ్చు బై యూజింగ్ Cayley Hamilton theorem చేయొచ్చు, లేదు అంటే యూ కెన్ ఫైండ్ బై యూజింగ్ దిస్ వన్ ప్రాపర్టీస్. సో దిస్ ఈస్ ఫర్ ప్రాపర్టీస్ ఆఫ్ ఐగన్ వాల్యూస్. దిస్ ఈస్ డైరెక్ట్ మెథడ్, డైరెక్ట్ వాల్యూ సబ్స్టిట్యూట్ చేయడం. క్యాలిక్యులేటర్ లో చేసేసి ఇక్కడ సబ్స్టిట్యూట్ చేస్తే యూ విల్ గెట్ వన్ మ్యాట్రిక్స్. ఫర్ దట్ మ్యాట్రిక్స్ యూ నీడ్ టు ఫైండ్ ది ఐగన్ వాల్యూస్. అదర్వైజ్ యూ కెన్ ఫాలో Cayley Hamilton theorem method. So after finding the matrix you can find the eigenvalues. Okay, here also same, by using the properties of eigenvalues you can find the eigenvalues like this. Okay, then simplify cheste you will get the eigenvalues. So మీరు ఏ మెథడ్ యూజ్ చేసినా you can find the eigenvalues, right? So now tell me what are the required eigenvalues here?
4, 34, 110.
4 ఎలా చేసినా మనకి ఇదే రావాలి ఆన్సర్ వచ్చేసి. ఐగన్ వాల్యూస్ ఆర్ 4, 34, 110. దట్స్ ఇట్. ఓకే, క్లియర్? ఇస్ క్లియర్ ఆల్ ఆఫ్ యూ?
Yes, ma'am.
వెరీ గుడ్, వెరీ గుడ్. మీ ఇష్టం ఏ మెథడ్ అయినా యూజ్ చేయండి. బట్ ఏంటంటే మనకి సిలబస్ లో ఉన్న మెథడ్, డైరెక్ట్ మెథడ్ కాకుండా, అంటే నో నీడ్ టు యూజ్ క్యాలిక్యులేటర్ అండ్ డైరెక్ట్లీ యూ కాంట్ సబ్స్టిట్యూట్ ది వాల్యూస్ హియర్ బికాస్ వీఆర్ ఇన్ సెకండ్ యూనిట్ నో. సో దట్స్ వై you can use any one of the method. Either you can use properties of eigenvalues and eigenvectors, or you can use Cayley Hamilton theorem. Okay. Otherwise, you can use the diagonalization method also, ma. Okay. So now coming to the next question. Tell me whether the given matrix is diagonalizable or not. Fifth question. See. So how to check whether the given matrix is diagonalizable or not? First, you need to find the eigenvalues. Otherwise, one more method is there. Cheppandi, anyone? So how to check whether the given matrix is diagonalizable or not? Yes.
Eigenvalues should be distinct.
If the eigenvalues are distinct, you can directly say that that is diagonalizable. The given matrix is diagonalizable.
If
So,
modal matrix is singular, then we can say not diagonal.
Yes. If the modal matrix is not singular, then we can say that that is diagonalizable. If it is singular, then we can say that that is not diagonalizable. So otherwise, you can find the diagonalize the matrix. Okay. So one more method is there. First of all, you need to find the eigenvalues for this particular matrix by using the characteristic equation. So for every method, so you need to find the eigenvalues. So what are the eigenvalues for this particular matrix?
5 minus 3 minus 3.
5 minus 3 minus 3. Okay. So ఇందాక వాడు చెప్పినట్టు ఏమన్నాడు వాడు? ఏమన్నావమ్మా ఇందాక?
Repeated
eigenvalues అయితే కాన్ diagonalizable. Distinct eigenvalues are definitely diagonalizable. But if the eigenvalues are repeating, no, in that case, those may
or may not be.
or may not be diagonalizable. Okay. So then how can you tell whether the given matrix is diagonalizable or not? Excuse me. Yes. Think and tell me. So whether the given matrix is diagonalizable or not?
If it possesses n linearly independent vectors.
Yes. So that means algebraic multiplicity is equal to geometric multiplicity. So then we can say that that is diagonalizable. Okay. So for 5, what is the algebraic multiplicity?
1.
1. So algebraic multiplicity is 1. For 3, algebraic multiplicity is
2.
2. So now we need to find the eigenvector. Okay. So eigenvector for lambda equal to 5. So otherwise, you can reduce the given matrix after substituting lambda equal to 5 here, not this one, this one. So substitute lambda equal to 5 in a minus lambda I into x equal to 0. Okay. So from that, if you get one matrix, now you have to reduce the matrix into echelon form. So after that, you can find the rank. So if n minus r is equal to 1, then am equal to, for 5. Okay. So am equal to gm, isn't it? So geometric multiplicity is nothing but n minus r. So n means order of the matrix. N means order of the matrix or number of variables or number of unknowns. Okay. So what about r? R is nothing but rank of the matrix. So after converting the given matrix into echelon form, you will get the rank. Okay. So if algebraic multiplicity is equal to geometric multiplicity, then we can say that that is diagonalizable. So if algebraic multiplicity is not equal to geometric multiplicity, then we can say that that is not diagonalizable. Okay, is it clear, all of you? So here also you can use any method. Directly you can find and check whether it is diagonalizable or not. That means you need to find eigenvalues, then find eigenvectors. So after that, write the modal matrix. If it is 3 by 3 matrix, you can write like this: P equal to x1, x2, x3. So now find D equal to P inverse AP. If D equal to P inverse AP, so then if you get 5 0 0 0 minus 3 0 0 0 minus 3, no, so in that case we can say that that is diagonalizable. Okay, if you get this matrix, no, then we can say that that is diagonalizable. So otherwise, if you can't get this particular matrix, no, then we can say that that is not diagonalizable. So otherwise you can find direct method also. Okay, so if am equal to zm, then it is diagonalizable for lambda equal to 5. So if like that, you can find for lambda equal to 3. Okay, so if am equal to zm, then we can say that that is diagonalizable. Okay, clear, all of you? You can use any method. But one thing you have to remember one thing. So that is always distinct eigenvalues are diagonalizable. Okay, distinct eigenvalues are always diagonalizable, but the repeated eigenvalues are maybe diagonalizable or may not be diagonalizable. So here also same one more question is there. So what is our sixth question? Determine the modal matrix. That's it. Determine the modal matrix. How to find the modal matrix? Yes?
The eigenvectors.
Yes. So first we need to write the characteristic equation, then find the then find the roots of the characteristic equation. Okay, so then, but if the eigenvalues are like this, no, you can find the eigenvectors for lambda equal to 1, lambda equal to 2, lambda equal to 3. So that means here you will get x1, x2, x3. So what is modal matrix? So modal matrix P equal to x1, x2, x2, x3. So that's it. So you need to find up to modal matrix. Okay, clear? Next. So what is our next
Excuse
question?
me, ma'am.
Yes.
Ma'am, in fifth sum, should we find the diagonal matrix?
No need.
Okay, ma'am.
Because in the question they have mentioned, no, determine the modal matrix. That's it. You need to determine. You need to find the modal matrix.
Ma'am, I'm asking about fifth sum.
Fifth,
Yes, ma'am.
we already have told, no, you have two methods are there to check whether it is diagonalizable or not. Okay, so first method is you can find by using diagonalization method. So up to diagonalization you need to find. Okay, so otherwise
Okay,
you
ma'am.
need to check by using am equal, if am equal to gm, then it is diagonalizable. If am is not equal to gm, then it is not diagonalizable. Okay. Okay, next question. Show that the matrix is skew Hermitian and find the eigenvalues and eigenvectors. So what is skew Hermitian matrix? Skew Hermitian.
A power theta equal to minus A.
A power theta equal to minus A, then we can say that that is skew Hermitian. So first you need to prove. So the given matrix is skew Hermitian. So after that, find the eigenvalues and eigenvectors for this particular matrix. Okay, so how to find the eigenvalues? Same procedure you have to follow. So first of all, you need to write the characteristic equation. The characteristic equation is 0 minus lambda I 0 minus lambda. So that is equal to 0. Okay, so then from that you can find the eigenvalues in terms of lambda square. Then you can find the roots. So roots of the characteristic equation is nothing but eigenvalues. So after that, you can find eigenvectors also. So what are the eigenvalues for this particular matrix?
I minus A.
I?
Minus A.
What is first eigenvector and second eigenvector?
1 1
1 1
minus 1 1.
minus 1 1. Okay, so this is the answer. Now, coming to the next question, verify Cayley Hamilton theorem for A equal to 1, 4, 2, 3 and evaluate. Already we have done, this is same like the first problem, right? So find the characteristic equation. After that, by using Cayley Hamilton, first of all, you need to verify the Cayley Hamilton theorem. So after that, you can find up to order 5, then substitute and simplify. Evaluate means you can find the matrix also. Okay, if the answer is like 6a plus 10, I know. So you can substitute a value here. So this is 1, 4, 2, 3 plus 10 into I means 1, 0, 0, 1. Okay, after simplification, you will get the matrix. Okay, clear? Now coming to the next question, use Cayley Hamilton theorem to find a power 8. Okay, so how to find a power 8? So can you tell me what is the characteristic equation for this particular matrix? Fast.
Lambda square minus 5 is equals to 0.
Lambda square
Minus 5 is equals to 0.
Ma'am,
yes.
ma'am, 8th question lo అది మొత్తం సాల్వ్ చేయాలి మ్యామ్ పాలినామియల్ గా.
పాలినామియల్ సాల్వ్ చేసేసి దెన్ దీన్ని సింప్లిఫై చేస్తావు. ఓకేనా, తెలుసు కదా, నేను ఆల్రెడీ చెప్పాను. ఫస్ట్ క్వశ్చన్ సేమ్ లైక్ ఫస్ట్ ప్రాబ్లం ఇన్ పార్ట్ ఏ. సో see here 6 lambda square minus 6 lambda plus 5 equal to 0. If the equation is like this, no, a square minus 6a plus 5i equal to 0. Okay, so a square equal to 6a minus 5i. So you can find a cube, a power 4, a power 5. So substitute first a power 5 here, then simplify, then a power 4 value here, then simplify. In the next step, you have to substitute a cube value. So like that, you can simplify this one. So if you get that value is that value in terms of the linear polynomial. Okay, so linear means order should be 1. Okay, so if the answer is 6a plus 10, I know, you can find the matrix. Okay, you can find the matrix. That's it.
ఓకే మ్యామ్.
Okay. So next question, coming to the next question, what is our next question? Use Cayley Hamilton theorem to find a power 8 if 1 to 2 minus 1. Okay, so the characteristic equation is lambda square minus 5 equal to 0. Here already they have mentioned, no, use Cayley Hamilton theorem. By Cayley Hamilton theorem, what is the equation? So this is a square minus 5y equal to 0, isn't it? Here no need to verify, because in the question they have not mentioned that verify Cayley Hamilton theorem. Just you have to use Cayley Hamilton theorem, right? So a square equal to 5y, isn't it? So a square equal to 5y. So a square equal to 5y. So then how to find a power 8? Before that, can you tell me, so x power m into x power n equal to?
Power m plus n.
Power m plus
X power m all power n equal to
X power m.
mn. X power m into n. So here I am taking the power 4 on both sides. So a square whole power 4. So plus 5y whole power 4. Okay. Then this will be
625i.
yes, this is, so x power m all power n means x power mn. So that is a power 2 into 4, that is 8 equal to, this is
625i.
Okay, so if you want to find the matrix, no, you can write 1 0 0 1. So then you will get okay, clear? Okay, now coming to the next question, 10th question, is the matrix is diagonalizable or not? So already we have discussed, no? So what about the eigenvalues for this particular matrix? Tell me.
1 2 2.
1 2
Very good, because this is upper triangular matrix. So that's why the diagonal elements are the eigenvalues. So this is 2 2 1. Is it clear, all of you? Now coming to the part B. So diagonalize the matrix A and find A power 4. Okay, so how to do the diagonalization of a matrix? So first you need to find the characteristic equation. So after that, find the eigenvalues. Okay, so because it is 3 by 3 matrix, now you will get the 3 eigenvalues. So then find the eigenvectors. Okay, so you need to find the eigenvectors for the corresponding eigenvalues. Okay, so then you need to write the modal matrix. So what is modal matrix? P equal to x1, x2, x3. So then you need to write the diagonalization of matrix D equal to P inverse AP. So from this you can find P inverse by using calculator, no problem, no issue. Okay, so after that substitute all these values here, then you will get the matrix will be in the form of lambda 1 0 0 0 lambda 2 0 0 0 lambda 3. Okay, so this is diagonalization of a matrix. Up to here, this is diagonalization of matrix D equal to. Okay, so this is D equal to this one. So then how to find A power 4?
A power n is equals to P into D power n into P inverse.
P inverse. Okay, so from that A power 4 equal to P D power 4 P inverse. So D power P is this one. From that we can find P inverse. And what about D power 4? Lambda 1 power 4 0 0, because this is D, right? So from that we can write D lambda 1 whole power 4. If you have 1 0 0 0 2 0 0 0 3, no, then D power 4 is nothing but 1 power 4 0 0 0 2 power 4 0 0 0 3 power 4. Okay, so then substitute all these values here and you can simplify this one. Otherwise, substitute all these values are these matrix here. Okay, substitute P matrix here and D power 4 matrix here and P inverse matrix here. Then directly you can do with calculator and write the matrix here. Okay. So do you know how to find A power 4 in calculator?
Yes, ma'am.
Okay, you can do with calculator, then write the answer here. Okay. And now, next question. So what is the next question? Determine the modal matrix P. So here also same, you need to find just a modal matrix. What is modal matrix? Modal matrix P equal to x1, x2, x3. That's it. Up to here you can find. What is our next question? Verify Cayley Hamilton theorem. Okay. So our next question is verify Cayley Hamilton theorem for A equal to this one and find A inverse and A power 4. So first you need to verify, don't forget to verify the Cayley Hamilton theorem. So first you need to read the question carefully. So after that you can do the problem. Okay. So first of all, verify the Cayley Hamilton theorem. So then find A inverse and A power 4. How to do this problem? Just you need to find the characteristic equation. If it is 3 by 3 matrix, no, you will get some lambda cube 6 lambda square plus 3 lambda plus 9 equal to 0. So let us assume that this is our characteristic equation for this particular matrix. No, in that case, how to verify this one? So by using this left side value, you have to prove that right side will be is equal to 0. Instead of lambda, you need to put A. Okay, so that is A cube minus 6A square plus 3A plus 9 into I. You have to prove that that will be null matrix. Okay, so this is verification, just verification. So next we need to find A inverse. So how to find A inverse? To find A inverse, you need to multiply this for this polynomial or equation. This is A cube minus 6A square plus 3A minus 9i equal to 0. For this equation, you need to multiply with A inverse on both sides. Okay, so from that you can find, you will get A inverse. Okay, So after that, you can find the A inverse by using calculator, and you can find or you can write the A inverse value here. Okay. So now how to find A power 4, Amma?
Divide and multiply on both sides.
Multiply with A on both sides. Okay. Now coming to the next question, find the eigenvalues and eigenvectors of the matrix. Easy, no? First you need to find the characteristic equation, then find the eigenvalues, then eigenvectors. Okay. So here also same, find the eigenvalues and eigenvectors for this Hermitian matrix. Okay, no need to verify whether it is a Hermitian or not. Just you need to find. So they are what he is saying. So the given matrix is Hermitian matrix. Just you need to find the eigenvalues and eigenvectors for that particular matrix. Okay. Now coming to the sixth question, verify Cayley Hamilton theorem. So already we have done this type of question, right? So A equal to 1 to 2 minus 1 and deduce A power 8 equal to indakadadi kuda ade anukunta kada.
Yes, ma'am.
Yes, repeated question. Next, coming to the next question, seventh one, determine the eigenvalues and eigenvectors of the matrix. That's it. You can find the eigenvalues and eigenvectors for this particular matrix. Okay, easy. Next, coming to the next question. Find the characteristic polynomial of the matrix A and verify Cayley Hamilton theorem. Same procedure. Just use Cayley Hamilton theorem and verify. First, you need to verify the Cayley Hamilton theorem and find A inverse and A power 4. Next, ninth question is diagonalize the matrix. If possible. So if it is diagonalized, no, you can find diagonalize the matrix. Otherwise, you can't diagonalize the matrix. Okay, show that A equal to is a skew Hermitian matrix and unitary. Already we have done this problem in the classroom, right? So first we need to verify, or we need to show that the given matrix is a skew Hermitian, means A power theta equal to minus A. So then you have to prove that that is unitary matrix. So what is unitary matrix? A into A power theta equal to I. So after that, you need to find and eigenvalues and eigenvectors. Okay. So after that, you need to find the eigenvalues and eigenvectors of this particular matrix. Next, find the characteristic roots of the matrix. Characteristic roots ante characteristic roots.
Eigenvalues.
Eigenvalues. Characteristic vectors.
Eigenvalues.
Eigenvectors. Okay. Characteristic roots and characteristic vectors. Next, coming to the next question. Wait for 2 minutes. Okay. Next, show that the matrix A equal to 1 minus 2, 1, 1 minus 2, 3, 0 minus 1, 2 satisfies its own characteristic equation. Means here we have to use Cayley Hamilton theorem and find the A inverse. Its own characteristic equation. It satisfies. So what is the statement of Cayley Hamilton theorem? Every square matrix satisfies its own characteristic equation, right? So that's why here we have to use Cayley Hamilton theorem. Okay. So here also same, use Cayley Hamilton theorem and find. Next question is find the eigenvalues and eigenvectors of the matrix and find its inverse. You can use any method because here they have not mentioned whether you have to use Cayley Hamilton theorem or anything. Okay. So and in the 16th question. So what are the eigenvalues for this matrix, Amma? 15th one. 1, 2, 3. Yes. Next, 16th one, show that the matrix satisfies its own characteristic equation. That means its characteristic equation means we have to use Cayley Hamilton theorem. And coming to the 17th question, verify Cayley Hamilton theorem and find it the inverse of the matrix. Here also you can use Cayley Hamilton theorem. Okay. And 18th one is diagonalization of a matrix, right? Diagonalization of a matrix. Okay. So next one, 19th one is show that the matrix satisfies it. This is also Cayley. All questions are quoted from the Cayley Hamilton theorem only, right? Almost. But you have to follow. They will give the linear dependent and independent questions and diagonalization of the questions along with the eigenvalues and eigenvalues vectors. Okay. So you have to go through. We have 4 methods. So what are the methods? Tell me. First one is eigenvalues and eigenvectors. And the second one is diagonalization of a matrix. And third one is linearly dependent and independent. And the last one is Cayley Hamilton theorem. Okay. So follow these 4 methods. They will give any question from these 4 topics. Okay. But in the mid-exam, they will give only these questions. Okay. Okay, ma, thank you. Any doubt in the second module? Yes, what happened? ఏమన్నా డౌట్ ఉందా? డౌట్ ఉంటే చెప్పేసేయండి. Okay. So tomorrow we'll start our third module, Amma. So all of you learn continuous function and differentiable function. So what is the difference between continuous function and differentiable function? Okay. I will ask the questions from those definitions. Okay. So after that, we'll discuss about Rolle's theorem. Okay, ma, thank you. Bye.
So this is the square development of square tray. So this is completed, one. So next we are trying for inclined square tray. So thank you for watching this video.
अब स्ट्रेट स्निप की सहायता से हम ये टुकड़ा काट लेते हैं 160 बाई 180 का.
So this is the rounding experiment which you can see here.
रेखा को देखते हुए स्निप चलाएंगे.
The before video we are seeing regarding the rectangular tray. Now we are seeing regarding the rounding experiment.
ये टुकड़ा हमने प्राप्त कर लिया सिलेंडर बनाने के लिए. इसको राउंड करना होगा और ये दोनों हिस्से 5-5 mm एक दूसरे के अपोजिट